today. We're going to find volumes of pyramids and volumes of cones. And kind of like we did with prisms and cylinders, the reason they're together, as it turns out, they have the same volume formula. All right? So this is section 12.5 in our book. So turn over to page 857. All right, if you look at the figure at the right here, at the top of page 857, it says the pyramid and prism at the right have the same base and height. So they've put the pyramid inside of that prism. Well, you can see that the volume of the pyramid would be less than the volume of the prism. All right, so the volume of the pyramid is some fraction of the volume of the prism that has the same base and the same height. Turns out it's 1/3 of the volume of the prism that has the same base and the same height. Since that's the case, that gives us this formula. For a pyramid, volume equals 1/3 times the area of the base times the height. So it's the same kind of thing we were doing yesterday. Now you got to take 1/3. And like yesterday with prisms, it depends on what they give us. If the base is a square or something that's easy to work with, then these problems tend to be fairly easy. If they don't give us all the information we want, then we'll have to draw in our own lines and make right triangles and figure out the things we need to find the area of the base and to find the height. Okay? Let's start with number 1. So over on page 860, find the volume of each pyramid. Now, like we had to do yesterday with the prisms, we need to identify the base. And remember that the height of the pyramid must be perpendicular to the base of the pyramid. So you see the little segment there that's 10 inches that's marked as being perpendicular to that triangular base? Let's take that then. So that's the height of the pyramid. So that means we need to take that right triangle on the base, or as the base. I'll get it out sooner or later. Since the 10-inch segment is perpendicular to that right triangle on the bottom, the 10-inch segment is the height, which means that right triangle on the bottom has to be the base. Now, try not to fall for thinking the base is always the bottom. With pyramids, yeah, it's kind of awkward to draw them any other way. But if you look at number 10, they just draw it upside down where the base is at the top. So the base is the base, not because it's the bottom, but because we have a height that's perpendicular to it. So we need to do the same thing we were doing yesterday. Let's find the area of the base. Since the base is a triangle, the area of the base is 1/2 times the base of the triangle times the height of the triangle. Now, it's a right triangle. So one of the legs can be B, the other leg can be H. So 1/2 times 9 times 5. Well, I know that 9 times 5 is 45. So what's half of 45? So the area of the base is 22.5 square inches. And now we're ready to find the volume. So volume for a pyramid equals 1/3 times the area of the base times the height. 1/3 times, well, we just found that the area of the base is 22.5 times, and they gave us a height of 10. All right, now I can do this without my calculator. This part I can. 22.5 times 10, I just have to move the decimal one place, don't I? And get 225. Okay. Now, 1/3 times 225 is the exact same thing as 225 divided by 3. And for one of the few times today, we get a whole number. So 75 cubic inches is the volume of that pyramid. Any questions on number one? You get the feeling that's about as easy as they're going to get? Yep, that's about as easy as they're going to get. Let's take a look at number two. What's the base of this pyramid? Pentagon. And what do you notice about all five sides of that pentagon? They're congruent. Okay, so we've got ourselves a regular pentagon here. Now, let's look at our different segments here. The 4.4 centimeters is the length of one of the edges of the pentagon. What's the 12 centimeters? That's the height of the pyramid. What's the 3 centimeters? The apothem. All right. I kind of wish they hadn't done this. You know, that on the paper, that's one big long segment. In the actual pyramid, was that what it would be? No. The dotted one is coming straight down from the top of the pyramid, hitting the base. Then the apothem is going from the center of the base out to the edge of the pentagon. All right. So I wish they'd drawn that to make that a little more obvious, because it doesn't look that way. But that's what's going on. Y'all with me? All right. Well, look, they even cut us a break here. They gave us a pentagon as the base, but they gave us the apothem. And they gave us a side of the pentagon. So getting the 1/2 apothem times perimeter, they've made that about as easy as they can make it. So the area of the base, since it's a regular polygon, equals 1/2 apothem times perimeter. So that'd be 1/2 times 3 times, now the perimeter, 5 sides times a length of 4.4, and we get 22. Well, half of 22 is 11. 3 times 11, we'll get 33 square centimeters. With me? Volume of a pyramid equals 1/3 times the area of the base times the height of the pyramid. 1/3 times 33 times 12. Well, what's 1/3 times 33? 11. What's 11 times 12? So we get 132 cubic centimeters for the volume of that pyramid. All right, still with me? Okay, let's keep rolling. Number 3. Find the volume of a rectangular pyramid. When they call a pyramid a name like that, they're telling you what the base is. A rectangular pyramid has a base that's a rectangle. A triangular pyramid would have a base that's a triangle. Okay? So the base is a rectangle. This pyramid has a height of 5.2 meters and a base that's 8 meters by 4.5 meters. So even though we don't have a drawing, the area of the base, since the base is a rectangle, and then they give us the length and width, or the base and height of the rectangle, so the area of the base is going to be 8 times 4.5. I'd really hate to miss this because I mismultiplied in my head. So 8 times 4.5, and I get 36 square meters. All right, finish it up from here. You know what to do. Get what I got? Oh, I forgot to write the formula down, didn't I? Everybody happy? All right, do number 4. And that's the kind of answer I've been expecting all along. When you divide by 3, at the end, don't you expect to get a lot of decimals? Yeah. Just so far, they kept giving us either the area of the base or the height that was a multiple of 3, and it kept dividing out evenly. But I've been expecting this. Any questions on number 4? So, look, it's a lot like finding the volume of a prism, isn't it? If they give us enough information, these turn into fairly simple problems. Keep in mind, you need to be ready for the time when they don't, and you have to work for it. Don't be afraid to work for it. Draw in some right triangles and use some Pythagorean theorem or trigonometry or whatever you got to be able to find the information you need to get the area of the base and to get the height. All right, cones, our next learning target. Well, they're approaching it the same way here, okay? They give us a cylinder and a cone with the same base and the same height, and obviously the cone doesn't take up as much volume as the cylinder does that has the same base and the same height. And just like with the pyramid, it turns out to be 1/3 as much. So the same volume formula for a cone as there is for a pyramid. Volume equals 1/3 times the area of the base times the height. As with cylinders, since the base is always a circle, if you'd rather memorize that as volume equals 1/3 pi r squared h, there's nothing wrong with that. I stick with the 1/3 times the area of the base times the height because I don't want to have to memorize a new one. I will remember how to find the area of a circle when I get there. Okay? So that makes the most sense to me. And also, remember yesterday with Cavalieri's principle? This formula works whether or not we have a right pyramid or an oblique pyramid, a right cone or an oblique cone. The only thing to remember is if it's oblique, the height's not going to be the axis, okay? It's going to be some little segment, like this one is, that's outside of it if it's oblique. Or even maybe not even outside of it. If you don't lean it quite as far, if the cone is more like that, it might just be off center a little bit. That's the point I'm trying to get to you. The axis is going to be, the height's going to be off center if it's an oblique cone or pyramid instead of a right. Number 5. Find the volume of each cone. All right. Find the area of the base. Since the base is a circle, it's pi r squared. Now, The radius is 3.5 since the diameter is 7. And I'm not going to turn this into a decimal yet. I'm going to square the 3.5, but the area of the base is 12.25 pi square inches. Don't punch it in yet. Everybody with me? So, volume 1/3 times the area of the base times the height. 1/3 times 12.25 pi times 4. All right, 12.25 times 4 is 49. Now, I'm going to do this. Maybe, because, sometimes we're going to get lucky here, and whatever we come up with when we do that will be a multiple of 3, and the 1/3 will multiply by it, and we'll get a whole number. But not in this case, right? 49 is not a multiple of 3. So we can do this, though. I multiply the 12.5 times the 4. Now multiply that by 1/3. Call that 49/3 pi cubic inches. Now, the directions did say round to the nearest, and it says 10th. We'll do 100th. But I don't want you to forget, though, that exact answers are exact answers. I want you to be able to get the exact answer before you get the rounded answer. Okay? So, to follow their directions, yeah, you could have punched it all in that one step and gotten a decimal, but I really need for you to be able to get an exact answer as well as a decimal answer, okay? Because I know where your future's going, and I know when you're sitting in that same chair, when you're taking calculus, I won't accept a decimal answer sometimes. I will make you give me an answer with pi in it. Pi's all over calculus, by the way. So if you think it's going away, it's not. Pie. Sometimes we have coconut pie. Sometimes we have chocolate pie. Every now and then we'll have a pecan pie. But anyway, now I'm hungry. Thanks. That's y'all's fault. All right, so let's see what 49/3 times pi is. So, let's see, 49/3 times pi. So I get 51.31 cubic inches. Any questions on 5? All right, number 6. You'll have to find the volume of the cone. And even though they drew it at an angle, it is a right cone, because see how the axis they drew from the vertex to the center of the base is perpendicular. So it is a right cone, but they've finally given us one where we have to do some work. I'm so happy. All right, they give us the height of the cone. It's 11.5 centimeters. But they don't tell us the radius, which is what we need to find the area of the base. So we get to do some work first. So look what you got here. You've got the axis and a radius. Now, the cone is a curved surface. However, can't we take a segment from the end point of that radius up to the vertex and just make a segment out of it? And we have a right triangle. And they told us that we have an 18-degree angle there. I'm going to call that R for radius. And if it were up to you, would you use sine, cosine, or tangent? I would too. So the tangent of 18 equals opposite R over adjacent, 11.5. Then we solve for R by multiplying both sides by 11.5. So we get 11.5 times the tangent of 18 equals R. Are we going to be able to get an exact answer on this problem? Only if we leave some really ugly things in our answer. I'll show you that. Okay? So, we can now get the area of the base. The area of the base is pi r squared. So it's pi times 11.5 times the tangent of 18 squared. I'm going to call it that because anything I do to that, if I take the tangent of 18 and multiply it by 11, if I take the tangent of 18, I've rounded. Even if I have 19 decimal places on there, I've rounded. And I'm not going to. Okay? So, that's ugly, right? We're working with it. You with me? Volume equals 1/3 times the area of the base times the height. 1/3 times pi times 11.5 times the tangent of 18 squared. So that's 1/3 times the area of the base times the height. What was the height? Oh, yeah, that's where the 11.5 came from. And that will be centimeters cubed. And really, well, I can mess with it a little bit, but I don't want to. I can simplify that exact answer just a tad. You know, I would make that 11.5 squared times tangent of 18 squared. Then the 11.5 squared times the 11.5, I can call 11.5 cubed. So I can simplify that a little bit. Okay? But I'm calling that my exact answer. Now, all right, how to get the answer on the calculator. I'm going to take 11.5. I'm going to take, first I want to make sure I'm in degree. Make sure you're in degree. Because last time trig popped up on us and we weren't ready for it, a lot of you weren't. You'd reset your calculator or change the batteries or something, and you were in radian. Make sure you're in degree. All right, I'm going to go parentheses. 11.5 times the tangent of 18. Now, I got to close the parentheses on the 18. Now I got to close the parentheses that I started in front of the 11.5, and I square it. Times 11.5 times pi times parentheses 1/3. Now, I went out of order just a little bit because I wanted to get that big thing squared in there first. Have I got everything? And if I've done this correctly for the calculator's notation, it'll give me the answer. And I have. So I get 168.14 cubic centimeters. Now, I hope it's obvious that on a problem like this, I'm not going to be grading you for an exact answer. So if you've got it, use your calculator the way you need to use it to get that answer. And you need to get better at using your calculator. Lots of you have really expensive calculators that do lots and lots of stuff. There's probably a YouTube video somewhere that will take you 10 minutes to watch that will show you most of the things your calculator does. I don't know that. I'm guessing. There's a YouTube video for everything else. Okay? So, you know, be able to use your calculator. So, you do whatever you got to do to get that answer. I like that problem. I had to work. Any questions? All right. Number 7. Supposed to find the volume of an oblique cone. Do we care that it's oblique? No, I don't care. With a height of 10.5 millimeters, so good, I've got the height, and a radius of 1.6 millimeters. Do I have everything I need? Yeah, go. I'll race you. Oh, you already done? Did you get what I got? Are there any questions? If you didn't get what I got, see, I got the area of the base to be 2.56 pi, so make sure you got that. If you got that right, but you didn't get the same final answer I did, there's probably a calculator mistake somewhere. Any questions on 7? All right. Oops. Need to do that. Okay. Now, number 8 uses a term that we're not familiar with. A cone with a slant height of 25 meters. Now, first of all, they did not say an oblique cone. So if they don't say it's oblique, it's right. So it's a right cone. Now, what's a slant height? Well, let's go back up here to, no, where was it? This one. When I drew in this segment from the end point of a radius to the vertex, that segment is called the slant height. Okay? So that's what a slant height is. Since they gave us the slant height instead of the height, they're going to make us work for it, aren't they? So I think I'm going to like this problem. So we have a cone with a slant height of 25 meters and a radius of 15 meters. I'm not going to draw the whole cone. I'm going to draw the slant height, 25 meters, okay? The base is down here. It's got a radius of 15, so that's 15. And then the height of the cone, and it's a right cone because they didn't tell us it was oblique, so it's right. The height of the cone would go from the vertex down to the center of the circle. Can we find the height? Yeah, is it a Pythagorean triple? It's a multiple of what? It is. It's a multiple of 3, 4, 5, isn't it? That's the radius is 3 times 5. The hypotenuse is 5 times 5. So the height, the missing side must be 4 times 5. Good. That saved us some work, didn't it? The height is 20. Now we're back in business, okay? The area of the base is pi r squared. So that's pi times 15 squared. So that's 225 pi. Then the volume is 1/3 times the area of the base times the height. So 1/3 times 225 pi times 20. All right, so let's see what we get here. So 225 times 20 is 4,500. Oh, 3 is going to divide into that, isn't it? So let's go ahead and divide it by 3 and get 1,500 pi cubic meters. And then 1,500 times pi, and we get 4,712.39 cubic meters. Okay, so I'm enjoying this. They're making us work for it. All right. Number 9. The Sky Dome of the National Corvette Museum in Bowling Green, Kentucky is a conical building. If the height is 100 feet and the area of the base is about 15,400 square feet, find the volume of air that the heating and cooling systems would have to accommodate. Oh, wait a minute. Is this one easy? They've given us everything. They've told us that H is 100. They've told us that capital B is 15,400. Volume equals 1/3 times the area of the base times the height. So 1/3 times 15,400 times 100. And, well, 15,400 times 100, that'd be 15,40000. So that'd be 1,540,000 thirds cubic feet. Now, they did tell us to round. We'll go 100. So 154,000 divided by 3. So 5, 1. How many 3s is that? 4 3s? 0.33. So 513,000.33 cubic feet. 513,333.33 cubic feet. That was fun. All right. As they tend to do after we have several things to remember, they give us a little summary of the volumes of pyramids, cones, cylinders, and prisms. So if you get confused as to which is which, you can look on page 859 and find that. On page 860, do 1 through 20, 25, 31, 37, and 41 through 44.